Okay, we're going to look at solving two different types of equations. First, exponential equations. Second, logarithmic equations. So with exponential equations, there's two scenarios we could be discussing. Do they have the same basis or do they not? So let's start with the same base example. Let's suppose we had something like 4 to the 2x plus 1 equals 4 to the 9x minus 8. So since the bases are the same, we really don't have to do anything but honor the equal sign. And that is saying if that base is the same as that base, then that exponent must be the same as that exponent. So in other words, 2x plus 1 must equal 9x minus 8. So after we move all the x's to one side, maybe move all the numbers over here, 7x equals 9, x would equal 9 over 7. So that's probably the easiest case. The second case would be if they have different bases. Let's say, for instance, that we're looking at 27 to the x, and that equals 9 to the 2x plus 5. Well, the first problem we have here, obviously, is that the bases are not the same. Now, while you can handle this with logs, you probably don't need to because 27 can be rewritten as 3 to the third. Now, that x really wouldn't go anywhere, so we still have it. And 9 can be rewritten as 3 squared. Now, see how I still have x and I still have 2x plus 5. Now, there is an important rule that we need to understand here, and that is we need to understand that in cases like this, the exponents get multiplied. So, we have 3 to the 3x equals 3 to the 4x plus 10. So you had to distribute that there. Again, now the bases are the same. 3x equals 4x plus 10. Move the x's to one side. So x equals negative 10. Now, let's look at a case where the bases are not the same, and on top of that, you can't make them the same. That would be probably the most difficult case. Let's say you had something like 7 to the x plus 1 equals 5 to the x. In this case, since we don't have the ability to write the bases as the same base, we are going to need to find a way to bring these exponents down from where they are. So that's going to have to come down here somehow, and that's going to have to come down here. Now, we can't do that until we use log. So this would be the only time where you really need to introduce a log into the problem. You can do log or ln, and that's because of the property. If you have log of, let's say, 5 to the x, that is the same thing as x times log 5. So in a case like this, we would have x plus 1 times log 7 equals x times log 5. Now, in this case, what we need to do is we need to go figure out what that is, what log 7 is, and what log 5 is as a decimal. So let's go do that real quick. Okay, so log 7 is about 0.845. And then, of course, I'll be distributing that times x plus 1. Whoops. And that is equal to log 5 times x. So log 5 is about 0.699. And that's times x. So now at this point, you treat it like you would any other problem. 0.845x plus 0.845 equals 0.699x. Bring all the x's to one side. So we have 0.845 is equal to negative 0.146x. Divide out. And so x will equal negative 5.78. So that would be the most difficult situation you have to deal with, only because the bases were not the same. There's no chance of getting them to be the same. Now let's look at how to solve log equations. And now, in order to do that, we're looking for, again, some real specific stuff. Let's say you had log of 2x plus 5 is equal to log 3x minus, 7. Since, again, we have the equal sign here, we have a log equal to a log, then it stands to reason that that quantity must equal that quantity. So all we would need to do is set 2x plus 5 equal to 3x minus 7. Solve that. X equals 12. Let's look at a more intricate example, a little bit more difficult, right? What happens if I have log 3x minus 1 equals 6? And let's actually go further. Let's say that's a 2 down there, the base of 2. Now in this situation, since you have a log equal to a number, you can't set any quantities equal to each other because it's not a log equal to a log. So the easiest way to deal with this would be to handle this using what we call the loop-de-loop, right? Start here, rewrite this as an exponential expression. 2 to the 6th power equals 3x minus 1. Now 2 to the 6th, we have to go figure that out. That's actually 64. And now we just kind of go about our business. 64 equals 3x minus 1. 3x equals 65. And so x equals 65 over 3. Let's do one more. ln x plus 4 plus, let's make that minus ln of 5 equals 2. Okay, our problem here is we have multiple logs, and so that poses an issue because we need this to be one log. But lucky for us, we can use properties, and we know that when we have subtraction of logs, that's the same thing as division. So we have x plus 4 over 5 there, right? Now, where do I go from here? Well, remember, you do have a base here, and you do have a log, in essence, equal to a number. So how do I handle that? Again, we write it as an exponential function, right? So loop-de-loop, e to the 2nd power equals x plus 4 over 4. Now again, at this point you might be a little confused because you say, well, how do I solve that? Well, I need to get x plus 4 by itself. I have a 4 in the way, so why don't we multiply by 4? So that becomes 4e squared equals x plus 4. And to solve for x, take away 4, right? So x equals 4e squared minus 4. And you notice here, I'm not even worried about what the decimal is, e squared. I mean, I could find that out, but this answer is fine. So that is just a basic overview of solving exponential functions and log functions.